Hey everyone, today we're going to talk about how to set up a BabylonJS project properly. So you've probably seen a lot of playground examples, and you've seen HTML where they include a script tag and then all their JavaScript goes in a script tag, right? But what we want to do is we're going to use a bundler. We're going to set it up with physics, and we're going to make it so that you can include any other JavaScript or TypeScript libraries you want to along with Babylon in your project. And we're going to do an initial scene setup and show you just kind of how everything works together and get you set up for success so you can create any large game you want. So let's get started. To set up Babylon properly, we're going to want to have Node.js installed. So go to nodejs.org and click to download the most recent version or the most recent stable version. Once you've installed Node, we can go back to our text editor and open a new folder. And what we want to do is we want to initiate a project and then install our project dependencies. So to initiate a project, we want to say npm init-y, and this will create our package.json file. You can see it here. You can always go back and add details later. We just did -y for the default values for now. You want to add author in and things like that later. The next thing we want to do is install our project-specific dependencies. In this case, we want the game library, BabylonJS, so we do npm i-save. We want BabylonJS. We also want a physics engine for our project. In our case, we're going to use AmmoJS and the TypeScript version, so AmmoJS no hyphen, and then hyphen, AmmoJS hyphen typed. And then the last thing we want is something called regenerator runtime, and that allows our AmmoJS types library to work properly. All we'll have to do is import that when we get to our TypeScript file. So we say regenerator hyphen runtime. So we're installing BabylonJS, our game library, AmmoJS typed, our physics library to go with our game library, and regenerator runtime to make sure our AmmoJS is working correctly. Then hit enter and let those install. Next, we're going to be installing Parcel, and Parcel is a zero configuration bundler which will be doing most of the hard work for us, and we'll only have to configure a few specific things. So down in our terminal still, there's two ways to do this. The first way is to install it globally. You can say npm I for install, parcel-bundler, and then -g for global, and hit enter and let that install. The other way to do it is install it as a dev dependency within your project. You could say npm i-save-dev parcel-bundler and hit enter. Our last dependency for this project, if you're choosing to use TypeScript for your BabylonJS game, is you need to install TypeScript globally. If you don't want to use TypeScript for your BabylonJS game, then you can skip this step. But to install TypeScript globally, npm I for install TypeScript -g for globally and hit enter. If you're choosing to use TypeScript instead of JavaScript, we now want to make a tsconfig.json file. If you're just choosing to use JavaScript, you can skip this step. To create our tsconfig.json file, we'll say tsc. If this doesn't work, you might want to check if it's there first. tsc-version, hit enter. If it's not there, can your terminal trash can and reopen it, and it should be there. So tsc, and we want to say -init, and that's going to create our tsconfig.json file. And now we want to go through and uncomment some of these lines in our tsconfig.json file. So to do that, we want to scroll down until we see the word types, which is here on line 34 for me. I'm uncommenting it, and inside of here, I'm going to put BabylonJS because we're using BabylonJS. And then you can save it. Notice mine reformatted for me. I'm using a library called Prettier, which does the reformatting for me every time I save. So don't be alarmed if you see things move. Down further, we want to enable some of these options. So for example, let's make sure I get the right options here. We want to enable things like no implicit any, strict null checks. These two are good. And you can pick and choose, right? These are just ones that I choose to do. We want always strict. Where's that at? Did I miss it? Always, there it is, always strict. I'm going to go also for no unused locals or parameters. and these two, no implicit returns and no fall through cases in switch. And again, these are up to you. These are just the ones that I chose to uncomment. But the thing that is not up to you is you want to include BabylonJS in your types if you plan on using TypeScript. The others you can leave commented out if you'd want to. That completes the installation and configuration process. Now we want to create our index.html, our index.typescript file, and our style.css file, and get you set up so that you can make any game you want. Now let's create our index.html file. So click New File and type index.html. Go ahead and hit the exclamation point, and hit tab if that appears for you, like that, and it will automatically fill in basic HTML for you. If that does not appear for you and you cannot hit tab and do that, go ahead and write lines 1 through 3. You can ignore lines 4 through 6 and then write lines 7 through 12. Once you've done that, we need to link our style sheet and our index.ts or index.js file if you're using JavaScript to our HTML. We don't have those files yet, but let's make the links for them, and then we will add those files to make sure they're working. So to add the links, we're going to put the style sheet link above the title, on line 7 in my case. So I'm going to say link rel equals style sheet, and we're going to say href, and this is where we're going to put our style.css link, and then we're going to do // and closing bracket. Then we need the script. So down here on line 12, at the very bottom of the body, we're going to do script source equals, and we're going to say index.ts if you're using JavaScript.js. Since I'm using TypeScript.ts, and you will want a closing script bracket for this. Now above that, we're going to put the canvas that we'll be using in the JavaScript file shortly. We will take the canvas and we will select it there, and then we will pass it to the engine. But for now, let's just put a canvas, and we're going to give it an ID and call it render canvas like this, and close it. And now just above that, just to test to make sure everything's linked right, we're just going to do an h1, and we're going to say BabylonJS, and so that h1 will appear on our browser when we open it, hopefully. That's the goal. So now we can save this. We have our links to our style sheet and our link to our TypeScript file, but we don't yet have those made. So let's do that. Let's create the style.css. And in here, we're going to give the h1 a color of green just to confirm it's working. Save that. And now let's create the index.ts file, index.ts, if you're using JavaScript.js. And inside of here, we're just going to console.log hello from BabylonJS. You can put in there whatever you'd like. Save that. And so now we have our index.ts, our style.css, and we have our links to hook them up to the index.html. Now let's run it with Parcel and see what happens. To open this in the browser, we want to run our Parcel-Bundler on it. So to do that, we can say parcel index.html. If that doesn't work for you, put npx out in front. So npx parcel index.html if just parcel doesn't work for you. And you can hit enter, and you'll see that it will build a dist folder, and you're going to see its server is running at localhost 1234. So if you control click on that, you can go open it in your browser, and you'll see that it's green in BabylonJS, so that means that we have included the style sheet correctly. And if we inspect it with Control-Shift-I, or if you right click and go to inspect, and we can go to the console, and we'll see it says hello from BabylonJS. That means we have our script file hooked up correctly. And let's zoom in on that just so we can see it better. Now that we know everything is connected properly, let's go back to our index.html, and we can remove the h1. We'll no longer need that. Save it. We'll go to our style sheet, and we'll add in the styles that we'll actually be using. So we can remove the h1, and we want our canvas to be the full screen, and we want our game to be the full screen. So we're going to say body width, and the body is this body tag here from the index.html. we want to style that and say width 100%, height 100%, and we're going to give it a margin of 0 and a padding of 0. Underneath that, we're going to grab the canvas element. We're going to style that by selecting the ID, so hash render canvas, and we're going to give that a width and a height of 100%. So width 100%, height 100%, and save. Next, we want to go to our index.ts file and remove the console.log, and then we want to add a function, and we're just going to call it main. It returns void, and we could actually put our console.log inside of here. That's okay. We'll just put that there for now, and we're going to call the main function here. Next, we need to create our scene, and we need to get the engine. Next, we want to create a source folder, and that's where we're going to keep most of our TypeScript code, except for the index.ts file, which is what Parcel initially reads. So we're going to create a src folder. And inside of here, we're first going to create a file that gets our canvas. And it gets any DOM items we may have. So we're going to say DOM items.ts. And what this is going to do, we're going to get our items from our HTML and export them so we can import them into other places in our application. I'm kind of setting this up as so you can scale this as a larger project. This is why this is in a separate TypeScript file. And there's not much here because we only have the canvas, but you may have more HTML items that you want to get and use in other places. So for now, it's just one thing. So we're going to say export const canvas equals document dot query selector, and our canvas has an ID of render canvas. So we're going to say hash render canvas, and then we need to say as HTML canvas element if you're using TypeScript. If you're using JavaScript, you don't need this on the end. And now what we want to do is create our scene, and it's going to use this canvas element that we're getting from the index.html. So I'm going to create a new file called scene.ts, and inside of scene.ts we first want to import the Babylon library that we installed earlier. So import all as b from BabylonJS. And then we can say import. We want to get the canvas that we're exporting from here. So import canvas from DOM items. So the goal of this file is to export our engine after we instantiate it and export our scene after we create it. So we can say export const engine equals new b.engine. Okay, b is from our Babylon file, and we're going to pass it our canvas and a default value of true. So we're passing our canvas we get from the HTML file, which we got here, and we're importing to here. So we're passing our engine our canvas, and then we want to export our scene, which we haven't made yet, but we will. So we're going to say export const scene equals make scene, and we're going to create our make scene function below. So we're going to say function make scene. Make scene is going to return a scene, and inside of it here we need to say a new scene, and we need to pass it the engine that we made here. So we can say const scene equals new b.scene, and we're going to pass it our engine that we instantiated right up here. Now underneath this, well, first let's return the scene, which is fine. But in order for the scene to do anything, we need lighting and a camera, and we're going to set the background. So to do that, we're going to have 3 different functions that we'll make. One is create camera, like that. And for each of these, we're going to pass our scene into it. We're going to have create light, and we're going to have set background. And we'll create each of these 3 functions below. So let's start with our create camera function. So we're going to say function create camera takes in a scene of type scene. It's it's not going to return anything, just void, and we want to say b.scene here. There we go. And inside of here, we're going to create some variables. So we're going to say const alpha, and this is going to be a number equals something. Const beta number equals something. And so alpha and beta are going to be the angles at which our camera is placed. And let me show you an example of that. So alpha here, if this is 0 and this is pi and this is pi divided by 2, we're going to place our camera at pi divided by 4. So it's going to be somewhere between 0 and pi divided by 2. It's actually going to be right in the middle. So it's going to be here. It's going to be looking at our cube or whatever we place here from this side angle. So if it's a cube, instead of looking at it face on, it's going to be kind of looking at the corner of the cube. And then we're going to place our beta angle at pi divided by 3. So if this is 0 and this is pi divided by 2, this line where beta is here, this would be pi divided by 4. And we're actually just going to go a little lower than that. So it'll be pi divided by 3. Combined with this other angle, it's going to be out here. We're going to be kind of looking down and at the corner, or more of this corner of the cube rather than at the face of the cube. So it'll be about right here. Okay, and to put that into code, we want to say here math.pi divided by 4 for the alpha, and math.pi divided by 3 for the beta. And then we can say, give it a radius. And the radius is how far it is from the center. So back in the image, if the radius is, let's say 5, it might be like here. But if the radius is 20, it's probably going to be out here. So the bigger the radius, the further away you are from this center target point. And we want to be far enough out that we can see the whole center, the whole scene, but we don't want to be so far out that the scene is very tiny. So for now, we're going to say const radius number equals 8, and if it's more or less than 8, we can adjust that then. Also, you don't necessarily need this number here. TypeScript can infer that, so you could write it like this, but just for clarity, I'm putting it there. And then we need a target. So where is the camera looking at, right? So our camera's out here off to the right and up higher, and then we need to say, you know, where's it looking at? Is it looking up, down? We want it to be looking at the center of the scene. So it's 0, 0, 0. So we're going to say const target, and here I'm just going to say vector 3. And again, TypeScript can infer that this is a vector 3, and we'll need to say b.vector3. But it can infer that if you don't want to put that, equals new b.vector3, 0, 0, 0, like that. And the last thing we want to do is create the actual camera. We want to feed all these values into a new camera. So new arc, b.arc, rotate camera, and we need to feed it some values. So we need to give it a name so that if we want to manipulate the camera later, we can. We're just going to have one camera in the scene, so I'm going to call it camera. If you have multiple, maybe you call it camera 1, camera 2, it's up to you. We want to feed it the alpha angle, beta, just everything we have up there, radius, target, and it also takes our scene like that. And then we want to attach, we want to use attach control here to the canvas and set that to true so that we can move around with our camera. Now our camera won't do anything without a light, so we need to use the create light function, which we started up here but we haven't made yet. So function create light takes in a scene of type b.scene. Going to return void because we don't need anything here at the moment, and const light equals, and again you could call this b.hemispheric light if you want to add the type here. In this case I'm not going to, I'm just showing different ways that you can do this. TypeScript can infer that this is a hemispheric light, equals new b.hemispheric light. And we need to give it a name, just like we did for the camera. I'm just going to call it light. If you have multiple lights, you know, give it a more distinct, unique name. We want to include where the light source is going to be located at. So new vector 3, b.vector3, we're going to say 1, 1, 0, and that's our light location, and we're going to pass it the scene. And then we just want to, we're actually not going to return the light because we're not going to need it in our scene for now. But if you want to manipulate the light, and same with the camera, if you want to manipulate the camera later, you might want to return the light, or you might want to return the camera. But for now, we're just creating the light, so I'm not going to return it here. And the last thing we need to do is set ourselves a background for our scene. So we're going to say function set background, and takes in a scene of type b.scene, just like the others. Going to return void, and we're going to say scene.clearColor equals new color 4. I've tried color 3 with this, it doesn't work well for me, so I'm using color 4. The first 3 values are red, green, blue, and the last value is your opacity, right? And we want fully opaque in this case, which just means not transparent at all, so 1. And so this is going to be a black background that is completely opaque, not transparent. So save that. And now we have all 3 of these created. Also note here, if we're using this and we're not returning anything, we don't need to store it in a variable. We can just do that. And one more thing to note up here, you're going to notice this scene is squiggly, red squiggly lined on line 8. It's because we need to say b.scene. If you wanted to just say scene, you would say import scene from BabylonJS, like that. Now this is just another way to do it, right? If you want to get individual things. In my case, and here did it for color 4, so I'm assuming I had this issue with color 4 somewhere. Yeah. So I can say b.color4. So that's something you want to keep in mind, is just make sure you're putting, if you're importing all as b from Babylon, make sure you're putting b in front of your types. And if you try and use npx parcel index.html and run it, you're going to notice that it doesn't work, nothing renders, because we need to say engine.run render loop and pass it the scene.render method. And we're going to do that in our index.ts file. So in here we need to import a few things. Import all as b from BabylonJS. We want to import the regenerator runtime we talked about earlier, and this is just to make sure everything's working right. So import regenerator runtime / runtime, like that. And again, that one we won't do anything with, but it is there. Then we want to import our scene and engine that we exported here in our scene, right? We exported these. We want to import them in our index.ts file. So import scene engine. And again, you could do this all in one file. You could have made the scene in this file. I'm just separating it out so that if you want to do a larger project, you can see how this might be separated out and just be a little more clear. From /source / scene, yep, just like that. And you don't need to include .ts on the end, it knows, parcel knows. And then we want to import ammo, and we'll get to ammo in a bit, but we want to import it for now. Import ammo from, and that's from our ammo library from earlier. And to make this work, we're going to get rid of console.log, and we need to do is say engine dot run render loop, and we're going to pass it a lambda function here, an anonymous function, scene dot render method. Just like that, we can save it. And if you didn't already start up with npx parcel index.html, do that so you can see mine built. And if you go to your browser after running parcel index.html, you'll notice and refresh, you'll notice that the background is now black and our canvas is taking up 100% of our screen, which is what we want. Now let's include our physics engine. To include ammo, we actually want to make this an asynchronous function. So we're going to say async function, and instead of returning void here, we can't do that anymore. It needs to return a promise. So promise of void, like this. And then we need to use this library that we brought in. So we can say const ammo equals await and ammo. So we're going to create a new instance of our ammo and wait for it. Once that's ready, we can say const physics. And we're able to use await here because we're inside of async. That's why we needed to make it async. So const physics. and I'm going to give it a type here of b.ammo.js plugin. And again, TypeScript can infer this, so you don't necessarily need this type here, but just to show you another way, equals new b.ammo.js plugin. So this is the JS plugin from Babylon, that's why we have the b out front. We're going to pass it true, and we're going to pass it our ammo that we have instantiated. And we're storing all that, our new JS plugin instance, in our physics variable. Then from there we can say scene.enable physics, and we can say new b.vector3. We're going to pass it, these are our gravity, so 0. And then the downward value, or y value, it's just going to be Earth gravity for now, so negative 9.81 and 0. So x, y, and z values. Of course, the y value is down, which is at negative 9.81. Then we need to pass it our physics variable. Just like that. We can save, and now we have physics set up in our scene. Now, to make sure the physics works, we want to create a ground and at least a cube, right? Because currently, if we look here, we can see our scene, and physics might be working, but we can't prove it, right? Because we just have the black background. So let's create 2 files here. We'll start with our ground.ts file, and inside of here, we're going to create a ground for our scene. So import all as b from BabylonJS. We want to import the scene from scene, and that's all we need for imports. Then we want to create a make ground function, so export function, because we're going to import this in our index.ts file. Make ground b.mesh. It's going to return a mesh, so a type of b.mesh. We want our ground to be size 4, and you can experiment with the size. Again, you could include the type here if you want, so number, up to you. And then we can say const ground equals b.mesh builder dot create ground. Create ground is a built-in type, or a built-in mesh that we can use, is what I mean. We're going to give it a name, so just like the light and camera, it needs a name, and then it needs a width and a height, and for us that's going to be of the size, width and height that we declared up here. So width, size, height, size, that's an object. Then underneath that, we need to again pass it the scene. Notice the theme of passing the scenes to different builders. Underneath that, we need to create physics for it, or we need to create a physics imposter for it. So we can say ground dot physics imposter equals new b dot physics imposter. And we're going to pass this imposter our ground that we made here from our mesh builder. Then we want to say b.physics imposter .box imposter, and we want to give it a mass of 0, which means it's not going to fall down, it's just going to stay there. And we want to make this bouncy, so when our cube hits this, it bounces pretty good. So restitution of 0.9, which is just going to make our cube bounce a lot. And then we want to pass it the scene again. Okay, so we created our ground, we gave it to a physics imposter, and then we want to return the ground from the scene. Now we're returning the ground here in case you want to manipulate it later, and you can go back to your index.ts file. And inside of here, we want to import that function. So we can say import make ground. Yep, from source.ground. You'll see it auto-completed that for me. And we want to do this underneath the physics engine and above the render loop. So we can just call the make ground function and save it. Once that builds, let's go back here. And you'll now see we have a ground that we have a light shining on. You can kind of see the light reflecting. We have our camera, right? And we attached a control so that we can manipulate our camera. And now we want to create a cube that falls down and hits the ground, right? To prove that our physics works. So to make our cube, let's create a cube.ts file in our source folder, cube.ts. Inside of here, we want to import all as b from Babylon. Import our scene from scene. And then we want to export a make cube function. So export function make cube. It's not going to take in anything, and it doesn't necessarily need to return anything, so it could be void. But in case you want to use the cube and manipulate it later, b.mesh. And we want to then use the mesh builder again. So const cube. And just to be clear, it's of type b.mesh equals d.mesh builder create box. We're going to give it a name of cube, again the naming theme, and a size of 0.5, so much smaller than our ground because it's going to bounce off of our ground. Then we need to give it a position, so cube.position equals new b.vector3. We want it to be above our ground, so x and z are 0, but y is going to be 1, like that. And then we need to create a physics imposter for it, just like we did the ground, so cube.physics imposter equals new b.physics imposter, like that. We want to pass it our cube b.physics imposter box imposter, and we want to give it a mass this time of 1 and a restitution again of 0.9. So the mass is different this time, right? This cube actually has mass, where the ground doesn't have mass because we want it to stay in place. And we also need to pass it the scene. Then we can return the cube. Now we won't see the cube yet because we need to call this makeCube function in our index.ts. So let's go over here and call makeCube right above makeGround. And notice it imported it for me. If it didn't, you can import it. Save. So if we go back to our browser and hit refresh, now we'll see that we have a cube, and it's a very bouncy cube, and that's because we have the restitution so high on both the ground and the cube, but that makes it more fun, right? So refresh again, and of course the cube bounces again. And that's it. We have created a basic setup scene for BabylonJS. We have the lights, camera, the scene, the engine. We have created 2 meshes. We've applied physics to those 2 meshes. And now you can take this folder structure and you can copy it and paste it into a new project every time you want to start a new project. That way you don't have to set this up from scratch every time, right? Because this took about a half hour. Don't want to do this every time, right? You just want to be able to copy the folder to a new project and build from this, right? This is the foundation, and then you can build from it to create whatever game you want, which is pretty awesome. Don't forget to run npm install in your terminal to install the dependencies once you've copied and pasted this into a new folder or new project. And that's all for today. If you like this video, go ahead and drop a like and subscribe, and thanks for watching. We'll see you in the next video. Take care. Bye.